Hello, welcome to Latency Exchange. On this channel we discuss technical topics relating to low latency trading, concentrating on the exchange side concepts, technologies and processes. I'm Dave Beattie, a solutions architect specializing in low latency exchanges. In this first series of videos I will detail my architectural solution for a 24/7 low latency exchange. In this video we look at the new modules that are needed on all servers in the core zone and how these support the failover requirements of the non-stop low latency exchange. We will also look at new functions that are needed within the exchange applications. Smooth, rapid failover is the critical service that differentiates a 24/7 exchange from a traditional electronic exchange. While there is naturally some buffering capability within any exchange architecture, this is often minimized because it is conceptually at odds with the low latency requirements. There is also usually some capability to replay lost transactions, but these also create significant order of processing issues if one transaction is delayed while the other isn't. Failover generally happens for one of two reasons: device or process failures, or administrative requirement. In the first case, the target would be to have the service continue within 1 millisecond. Any trades that arrive in that time should be queued with a timestamp based on its arrival time. This is to support correct order of processing when the service resumes. It is assumed that such a delay would not normally be detectable by the trading institutions. In the event that a gateway service fails, obviously the trading institution will notice, but they will have resilience processes to handle this. In the case that an administrative requirement drives the failover, for example to support a maintenance period, the whole process is under the control of technical operations team, and seamless failover is expected. Now we introduce the next new category of servers, the command and control servers. They live in the management zone. This should be a cluster of 2 to 4 servers that use traditional high availability functions. Critically, they are the primary source of architecture information for the whole solution. All transactions within the core zone have an associated transaction ID. During an administratively driven failover, the aim is for one server to stop processing on one transaction ID and the next server to start processing on the subsequent ID. In practice, it is a little more complex than that. The command and control servers will select a transaction ID a little way into the future, say 10 seconds. This is then communicated to all servers in the core zone via the data injectors. Once all of the available servers have confirmed that they accept this action, the command and control servers will confirm that failover is set to happen. When the active server reaches the specified transaction ID, it does not process a transaction at that point. It simply logs the fact that it is no longer processing transactions under that ID. It then monitors the transaction log for the next message. The server that is set to take up the process then logs its acceptance of this under the next transaction ID, and it then continues to process from that point on. If the original server does not see the acceptance message and does not see transactions continuing, it will revert to its active role. In doing this, it must also log a revert message as the next transaction ID and continue to process from there. There are 4 server roles, and failover between these levels is carefully controlled. The server that is actually processing transactions is considered to be active. There is then a standby server, which is fully in sync with the active server. This should also be processing transactions in parallel with the active server, but not publishing the results. This is so that it is ready to take over in the event of a failure. The next role is the backup server. This is also fully synced with the active server, but does not need to be processing transactions. The final role is maintenance. At this level, the server can be taken out of service for maintenance work if needed. It can be brought into sync with the active server if necessary for pre-live testing. Any server may promote itself one place if it determines that the server in that role has failed. The only exception to this is the promotion from maintenance to backup. This must be initiated administratively because the server in a maintenance role may be an unknown or non-functional state. Similarly, under administrative control, any two servers in adjacent roles may be swapped. This means that to take a server from the active role down for maintenance will require 3 moves: active to standby, standby to backup, and finally backup to maintenance. Because the server with the backup role is synced with the active server, any data that needs to be extracted can be taken from there without burdening the active server further. How do we make all of this happen? The answer is with 3 new processes and a few new functions that must be available on all of the servers in the core zone. I'll now go through these individually. When a server first comes online, it must request the full system architecture from the command and control servers. This consists of a number of files that hold all of the information about all of the servers and services that exist in the core zone. The server will store this information within its architectural module. This is the first of the new modules needed for the servers. The server will then verify its own configuration against the architectural information that it has received. If everything agrees, it will bring itself up into the maintenance role and will wait to be promoted by a member of the tech operations team. Once this steady state has been achieved, the server will listen for architectural updates from the data injectors, not the command and control servers. This is to alleviate pressure on the command and control servers. The second module that is needed on all of the core zone servers is the command and control module. This registers its presence and status with the command and control servers in the management zone. It is responsible for interpreting its current functional capability and that of the infrastructure around it. It must initiate any action in response to changing conditions or in relation to instructions received from the command and control servers. Finally, it must continue to report its status to the command and control servers and send logs back via the data extractors. Once the server is online and has valid architecture information, the command and control module uses the information from the architecture service to program the final new module, the communications module. This is responsible for supporting all of the highly resilient communications that the server needs to participate in. This module specifically takes a single message from the relevant trading application and converts it into the 4 separate messages to be forwarded over the 4 separate physical paths. The communications modules on the receiving servers are responsible for deduplicating these messages and passing a single message up to their respective receiving applications. They're also responsible for reporting any missing messages through their command and control modules to the central command and control servers. With this collated information, device or process failures can be quickly identified and triaged. The first 2 new functions that must be built into the Exchange solution is the ability for a server to stop or start processing of transactions. This is needed to support the failover, specifically under administrative control. Protections must be put in place to rapidly revert these actions if the contraposed server is not successful. The final function is optional. This function allows a trading institution to submit an order on hold and then execute or rescind it. This is intended to mitigate trade sniping by minimizing the packet size needed to execute a trade that has been submitted on hold. Market behaviors and manipulations is a huge topic, and we may come back to this in a later video. The next few videos will look into the processes and performance tuning of the servers found within the core zone, starting with the matching engines. Thanks for watching. Please leave any questions in the comments and I'll reply to them as soon as I can.